Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson on the study of distribution maps. This lesson is a continuation of our previous lesson in which we learned about the different types of qualitative and quantitative distribution maps. In this lesson, we are going to focus on translating different data into distribution maps using various diagrammatic methods. This lesson will involve some math. Students, so please make sure that you have what you need to take good notes. Are you ready? Let us begin. Let us review what we have learned in our last lesson. Students, please take a moment to state the difference between chorochromatic maps and choroschematic maps. Go ahead, and I will see you shortly.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Well done, students. I am sure that was an easy activity for you. A chorochromatic map shows the spatial distribution of geographic elements using color tints, shading, dots, or line symbols. A choroschematic map, on the other hand, uses pictures and letters to represent geographical elements. These types of maps are the subgroups of qualitative maps, meaning that they do not show any numerical values. Excellent work. Let us do one more review activity before we move on. Students, last time we discussed 4 common types of quantitative maps. One of these is called dot maps. What must you do to create a clear and accurate dot map? Please work with a partner to answer this question.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Excellent work, everyone. I am sure you have excellent ideas about how to create a dot map clearly. There are 3 essential guidelines for making dot maps. You must be sure to place the dots accurately on the map. You must also be sure that there is enough space between the dots to distinguish them. If dots are clustered too close together, the values will not be clear. You must also make sure that all of the dots on the map are the same size. If you are careful, you should be able to produce a dot map that will present clear quantitative data. Now that we have completed our review of the previous lesson, we are ready to move on. Distribution maps can show both qualitative and quantitative data. For instance, let us consider a map showing precipitation. A qualitative map might show the distribution of different types of precipitation that fall in different areas. For example, rain, snow, or hail. A quantitative map showing precipitation might illustrate the number of millimeters per year that fall in different locations. Let us now focus on ways of translating different data into distribution maps using various diagrammatic methods. Some diagrammatic maps use proportional squares to make comparisons. The area of each square is proportional to the quantity it stands for. Students, as you will have seen in your textbook, there are 3 steps involved in showing distributions using proportional squares. Let us review the steps together. In step 1, you calculate the square roots of the given values. In step 2, you let the least square root computed represent a side of the square that measures 1 centimeter times 1 centimeter equals 1 centimeter squared. In step 3, you compute the side of the values in ascending order and draw the squares using the computed square roots. Let us look at an example. Here is the hydroelectric power potential for 3 of Ethiopia's rivers. The hydroelectric power potential for ceicteth is 300 megawatt. The Addis Ababa 2 and Koka Dam have hydroelectric power potentials of 73.6 megawatt and 43 megawatt respectively. Therefore, when the square roots of each of these values is computed, we get the following. The square root for the ceicteth River value is 17.32, and it is 8.58 and 6.56 for the Addis Ababa 2 and Koka rivers, respectively. These square root values will be used in millimeters to draw the squares on the map, resulting in 3 different squares representing the hydroelectric power potential of the rivers. Let us do an activity to practice this. Suppose that you are creating a diagrammatic map to show the distribution of disabled primary students in Dire Dawa and Addis Ababa. The number of disabled students in Addis Ababa totals 208. In Dire Dawa, there is a total of 320. Please determine the proportional squares of these values to show the distribution of disabled students in these 2 cities. Please begin, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. The proportional square for the value given of disabled primary students in Addis Ababa is computed by finding the square root of 208. The square root is 14.4. The proportional square for the value given of disabled students in Dire Dawa is computed by finding the square root of 320, which is 17.8. Therefore, the proportional squares on your map will be 14.4 millimeters to represent the number of disabled students in Addis Ababa and 17.8 millimeters for Dire Dawa. Good work, everyone. A circle can also be used to show the proportions of individual components. To draw proportional circles on a diagrammatic map, the least value being represented by 1 centimeter is selected, and the radii of circles for representing different values will be calculated. After the lesson, your teacher will guide you through some examples to practice calculating proportional circles. Students, this is the end of our lesson on the study of distribution maps. We have learned how to calculate proportional squares and circles on diagrammatic maps. In our next lesson, we will compare the properties of globes and maps. Until then, thank you, teacher. Thank you, students.